Hello everybody, welcome back to the second part of today's three-part lecture. Today we're going to be looking at kind of the opposing view and why you might believe it. And the first reason you might look at what's happening in terms of abiogenesis and what happened before that, oftentimes called chemical evolution, is that it requires fewer assumptions to think that a mind was responsible, right? Because there are as many as 100 factors that have been identified or hypothesized as necessary for complex life. Okay, this is just the preconditions. This isn't even the chemistry. Okay, it might be less than this, but that's still pretty high. And this a book, if you're curious about it, it's called The Privileged Planet, talks about a lot of these preconditions for complex life. Okay, then you run into problems with the chemistry. And I'm going to belabor this point a little bit, so hold on to your hats. Here we go. You need to have, okay, well, let me go back. In a cell, you have a chemical pathway, which is a series of chemical reactions, reaction A, B, C, D. And for every step, you're going to have an enzyme that catalyzes the reaction. So for step A, you have enzyme 1. Step B, you have enzyme 2, 3, 4, 5, C, D, etc. So on the other hand, outside of a cell, you have to deal with free energy in terms of temperature to cause the reactions, pH, maybe discharges of electricity. You have the autoionization of water, so you get OH group ions and H group ions. You may need to have the presence or absence of certain wavelengths of light. And then, of course, there's a timing issue, because once you get the conditions to, say, bond carbons together, they're going to keep bonding indefinitely till there's no more carbon unless the timing is just right. So there's a lot of factors that happen on top of the necessary setup for life to happen. So if the reaction is not long enough, you won't have a full molecule, and the reaction is too long, you'll have a very different organic molecule. You also have to have isolation from free radicals. A free radical could be maybe dissolved metals that are in the oceans right now, like iron and zinc and lead, gold, very trace amounts, not a whole lot, but they're there and they could interact with your particles. Chlorine and sodium, salt ions, could be interacting with your molecules in your early Earth environment. And so one of the problems is, how do you come up with a scenario where things are being separated? And then oxygen has been shown to be damaging to organic chemicals that are outside of a cell. And it's beginning to look like there was always very small amounts of oxygen present on the Earth. So let's say you have a chemical reaction. Oh no, the slides aren't showing all of my chemical reactions I worked so hard on. Okay, give me just a moment. I will have to, actually, perhaps I will go back and just delete those because it's a bit too esoteric for this class.